So hey everybody, today I'm gonna teach you Calculus 1. My name is Kavish, and yeah, so let's get going. So the first things that we're gonna talk about in Calculus 1 is tangent line. It's very important and the basic of calculus. So what is tangent line? Some of you may have learned what is tangent line in high school, but I'll get in more details in this video. So how about we get started? But before that, before get going, I would like to this should be good. Alright, so let me draw a graph for you guys. So normally you guys are supposed to know this equation of the line y equal to mx plus b. Make it less. Alright, so this equation can be written like this. Oops. Like so. And the equation of the slope is written like this. So this is not something new for you guys, as you may have guessed. This is the equation of the line. So let's write it here. This is the equation of the line. Yeah, so what we're gonna do is see this slope here. We're gonna use the slope to find the tangent line. Mostly this equation. We're gonna use this equation a lot of time to find the tangent line. The tangent line can also be written the instantaneous slope. Oops. Alright, so let's write a definition here. So definition: the tangent line is a slope that only touches one point on a curve. Alright, so yeah, obviously this is the equation of a linear function. What we're going to do in calculus is non-linear function. So we're basically evaluating curve like so. So this is let me do it one better. Yeah, this is what I'm saying for a tangent line. So this line over this curve, this is the tangent line touching only one point. And to make it easier for you guys, I just want to give you a reference. Here, equation is a line. I'm gonna do it. Slope is constant everywhere, except for a curve. A curve doesn't have a constant slope. So what it basically means is that, as you can see, to find the slope of one specific point, we need to do a tangent line. Except that finding the tangent line at one specific point doesn't tell us every point. Doesn't mean that every point has the same tangent line. So this point here have a different tangent line, as this point too have a different tangent line. Every point has a different tangent line. But so this is why the slope is not constant in a function. And later on you're going to see that we're going to do derivative to find those tangent line functions basically. So yeah, you guys just need to know what the definition of a tangent line, and a curve doesn't have a constant slope. Basically the slope is different at every point. The tangent line is different at every point. So this is about the tangent line. Okay, so let me show you guys what we're gonna do to find a tangent line for beginners like you guys. So let's make a function, a curvy function. So we're going to see those type of functions in calculus. So for example, let's choose point P. Let's take another color here. Let's give point P red. This is the tangent line for point P. A red line. Okay, tangent line. However, it's not easy to find the tangent line just by looking at it. Normally what you do to find the slope, you take 2 points. So let's write it. Normally, okay, normally you take 2 points. Take 2 points to find the slope. Okay, and this is how we normally do in high school. But here in tangent line, however, the tangent line only have 1 point. So how do we find the slope? Well, what we do is, let me take another color. Let's take green for example. Let's take here point Q, and we connect point Q and point P. This is our first tangent line with connecting point P and point Q. Let's call this Q1. So here we have a tangent line that is not a tangent line, we have a slope that connects to point P, but it's not the same as red. So slope PQ is not slope at P. Or you guys can just say they are the same but not quite. Okay, so what do we do to make it? Let me erase this. So what do we do? Let me just take like ish, but not quite. So what do we do to find the tangent line, to find the approximate tangent line? So let's take another color. Let's take the color blue here. We take another point Q, this time point Q3. We draw another tangent line. This time the slope connecting to Q3 to QP is closer. Okay, slope, this is PQ3, is closer to just the slope P slope P is close to slope P rather than let me just continue this. Oops. Is closer to QP, to slope P, than slope Q1. Let me just make it in green. Then slope. God damn it. Slope Q1. All right. Okay, so as you can see, the closer P and Q are, the better our tangent line is going to be. Okay, our tangent line is going to be more precise when we close up Q. All right, so let me just see something first. Alright, so let me just try something. Anyway, let me just put it in, excuse me for that. Alright, let's continue. I'm just trying to figure out how this works. So let's continue. Alright, so this is what the tangent line is about. So if we close up P, okay, let me just write it here. If we close, if you make that word P and Q closer to each other, will get a more accurate tangent line. This is how we're gonna first find the tangent line. Okay, so basically what you do is take a lot. You take like a lot of numbers close to P, and slowly plotting the numbers in our function, in our slope function here, to find the tangent line. So for example, let me just erase all of this. Okay, you guys can just pause the video and write it down. So now I'm just picking place. Alright, so let me just erase this as well. Okay, so let's take this. So let us do an example for you guys to understand it way more better, for it to be more clear. Find the tangent line find the tangent line in the following question. And this can also be written as tangential slope. Whatever you use doesn't matter. Okay, so let's see, y equal to 1 over parentheses 1 minus x. And let's take our point P. This is where we're finding our tangent line. Let me just write it. Let's just go back again. Let's find the tangent line at point P in the following function. So our function is going to be 1 over parentheses 1 minus x. Our point P is going to be 2 minus 1. And point Q, we don't know what point Q is because we are basically plotting a lot of basically what we're going to do is you guys can try and guess and do it on your own. It's already nice to do it on your own. Is basically taking x as it approaches 2. So we're basically taking numbers that is approaching 2. Because remember, we want to find what we're basically doing is basically taking the points on the curve that is close to P. Okay, basically there's a lot of numbers that is approaching P. So this is what we're basically doing. So instead of writing a lot of Q here, we are just gonna write Q, X, and Y is basically these functions. So we can just plot X instead of, we can just plot X in our equation instead of plotting X in the coordinates here. So let's take X that are approaching 2 for point P, right? So 1.5, 1.9, 1.999, 1.9999, 2.1, 2.1, 2.5, and let's take another one, 2.7. 1, 2, 3, 4. Okay. For now, that will do. Just gonna write this function for you guys to remember this. This is this is a slope, and the slope is basically a tangent line at one point. Just to remind you guys. Okay, so to find the instantaneous slope, we're using this equation. Okay. So how do we do this? Well, let me remind you is that in our function is the tangent line is connected to one slope, and what we're basically doing is taking slope approaching our main slope. So basically taking points that are closing up to our slope, approaching our slope. So let's do it. The first thing what we're gonna do, so it's basically take our first x. So m1 is equal to, just get way more space than this, m1 equal to our y1. This is going to be our y1, this is going to be our y2, this is our x2, this is our x1. Alright, to make it more clear to you guys, remember Q is a point on the curve. Okay, so let me just remove x here. So I'm just gonna plot 1.5 minus 1 and 1.5 minus 2, and we're gonna get if you do your calculation, we're gonna get 2. Alright, so let's take our second slope, our second x, excuse me. And 2 1 over 1 minus 2 in parentheses, no, I mean not 2, 1.9 minus 1 and 1.9 minus 2. When I get something, let me use my calculator. 1.1. Alright, so let's do this for M3, our third slope. So 1 minus 1, let me just check again, is 1.99. Okay, (1.99) minus 1, 1.99 minus not minus 1 minus 2 is gonna equal 1.01. And let's take M4 and let's write the function 1.999 minus 1 and 1.999 minus 2. I'm just gonna erase this part. That's gonna equal 1.01. 1.001. You guys should do it on your own to, you know, to keep up with me, because it's way more easier for you guys to understand. So let's do the fifth one. 1 minus 2.1 minus 1. Just gotta mark it here. We have done this, we have done this, we have 2 more to go. 2.1 minus 2. Oops, this is too big. This is gonna equal to 0.9, and there's a bar over here. So 0.9999999. 0.19, 0.19, 0.19, 19, 19, 19 to the infinite. So we can just approximate 0.1. So the sixth slope minus 1, 2.5 minus 2 is gonna give us 0.666. So we can just approximate it to 0.67. And finally, (2.7) minus 1, 2.7 minus 2. Let me just calculate it real quick. So it gives us 0.588 continuous. So we can just approximate it to be like 0.6. So what have we got for all of those? So let's just write it down. Okay, this is x, our x as my x approach. Let's write x here. Also, we have chosen 1.5. Here is 1.9, 1.99. Let's do this like this as well. You're going to see y. Here is to be 1 point. This is 2 here. My x is approaching 2. This is 1 point. This is 1 point. This is 2.1, 2.5, and 2.7. And for 1.5, we have gotten 2. So this is our slope. Right, slope or instantaneous. Let's write tangent line. Slope will be good. This is our slope. So here we have gotten 2 for 1.5. Yeah, 1.9 is 0.19. Here it's 1. Excuse me, it's not 0.19. It's 1.1. Excuse me. Here's gonna be 1.01. Oops, I forgot. 1.9. You just make more place. .99. Place here as well. 1.999, and let me write 2 here. So 1.99 we got 1.01. 1.9999 is 1.001. Okay. For 2.1 we got 0.19. 2.5 we got 0.67. 2.7 we got 0.6. Can you guess what is the slope for 2? Yes, in a matter of fact, we can all assume that it's 1, right? Because when x approaching from the left is approaching 2, as well for the right. This is x approaching from the right. Okay. So in a graph, it's well basically approaching x like this and like this. So what is, let's write our answer here. So the instantaneous slope at point P is 1. This can also be written as tangent line or rate of change. Doesn't matter how you say it, tangent line, instantaneous slope, or rate of change, all the same to me. Alright, so I'm just gonna do a recap. So to find the slope, we basically use this, and remember the tangent line uses the slope, so we have to use the slope equations: y1 minus y2 divided by x1 minus x2. And so to find the instantaneous slope, the tangent line at one specific point, well basically, I'm just gonna draw it again. This is our tangent line. This is our Q here. What basically doing is closing off Q. Q is approaching P. So at what point is going to be so close that's going to overlap. Right. So this is basically tangent line, but in a long way. So all of these took us quite a long time just to find the tangent line, but this is the beginning only. For this, I hope you guys get this. If you guys don't get this, rewatch the video again, take your time, and if you still don't understand, just comment down below what is not clear, and I'll make another video or explain it at the beginning of the second part. What is an instantaneous slope and how do we find it? Okay, so this is all about the tangent line. For now, let me just erase it. Let me just erase everything. And I hope you guys understood what I have done is this problem. Sorry, it's taking a bit too much time. Instead, or quite a lot here. So what I'm gonna do next is explain it to you how we find the tangent line faster. And this is going to be in the second video. In the second video is going to explain it to you guys how we find the tangent line using limits. For now, I'm gonna give you another example. This time you guys should do it on your own. So let's take a function, a new type of function. Let's take quadratic function. Yeah, very simple here. So this is our p. Our p is gonna equal to, let's take a random number. So let's take 4 to the power 2. It's gonna take 4 and 16. And our q is gonna equal to x and x to the power of 2. X to the power of 2 is basically our y. Hopefully I don't have to explain it to you guys why. Hopefully I don't have to explain it to you why we're using q for x and x to the power of 2 here. If you guys still understand, comment down below. So this is a new function. I want you guys to do it on your own and try it. It shouldn't be that hard, I hope. So if you guys have done this problem already, you can just correct yourself. Okay, so the first thing I'm going to do is write the function, my slope here, just to remind myself what I'm doing. So this is my function for my slope, to find my slope. So what I'm basically taking is taking my x that is approaching forces. So let's take 3.5, 3.9, 3.99. Let's take 4.1, 4.0. No, let's take it a bit more closer this time. 0.01, 4.1, 4.2. I have taken a lot of points here, but you guys don't have to do this. But I'm still taking multiple points to show you, to be more precise, to be more sure about it. So let's do this. Let's take our m1, 3 to the power of 2 minus 16. And yeah, so here it's going to be 3.5 minus 4. And so let's take our calculator. Minus 16, 3.5 minus 4 is going to give us 7.5. Let's take m2. 3.9 to the power of 2 minus 16, 3.9 minus 4. Take our calculator again. 7.9. Alright, let's do for the third slope. 3.99. Check again, 3.99. Minus 16, 3.99 minus 4. We'll have 7.99. Now let's take our fourth slope. M4, 4.01 to the power of 2 minus 16, 4.01 minus 4. Again, I'm gonna remind you guys that you don't have to get the same, you don't have to take the same x as me. You guys can take any x you want as long as it's close to my point P. Okay, as long as it's close to 4, I'm good. Okay, but you don't have to take point that is too far from point P. You have to be close to point P. Oops. So what is my answer here? My answer is gonna be 8.01. How about I'm 5? So this is 4.1 minus 16. 4.1 minus 4. We have 8.1, and last but not least 4.2. I think I'm very exaggerated with 4.2. Might be a little too far, but it's fine. Oops, this is 4.2 here. Minus 4. So let's take my calculator and find the answer. So 8.2. Hopefully you guys know where this is going. We got 7.5, 7.9, 7.99, 8.01, 8.1, 8.2. So let's see. I've taken 3 points at the left of. I have taken 3 points at the left of my point P, and 3 points at the right of my point Q of my point P as well. So left and right, and they're both approaching like this. You guys need to be reminded. So both approaching from like this. Okay. So my instantaneous, my tangent line. The tangent line at point P is equal to 8. Okay, this is an easy function I've given you, but normally we get way more complicated functions when we're using limits. And later on you're going to see what is limits. I'm just giving you small tips how we're going to use limits later on, because the way we are finding this the tangent line or the instantaneous slope is by plotting points in my function here. We're basically plotting x here, but it's the x and y. And not gonna lie, this take a bit too much time. We mathematicians like to make things a bit more easier, to find it way more faster. Hence why in the second video I'm going to introduce you guys to limits. And before we use limits with the tangent line, we're going to learn what is limits, what is the law of limits, and stuff with continuity. Then we're going to learn how to find the tangent line using limits. And after that, we're going to use the derivations, a way more easier way. So we have a lot to learn, and I hope that you guys enjoy this video, and like and comment if you understand. Okay, so have a great day.